The next chapter that we're going to look at deals with square roots, or otherwise known as radicals. In the first section, we're just going to talk about finding square roots. In order to do this, we want to be able to identify square numbers, and we also want to understand order of operations. Let's start with some basic vocabulary. A square root is the opposite of squaring, i.e., the square root of a equals b is the same thing as saying what squared equals a. The radicand is the number or expression inside the square root. For instance, if you have the square root of 7, 7 is the radicand. The principal square root is the non-negative root. We'll talk about this later when we get into solving equations. But for now, note that we will always be working with principal square roots. If the square root symbol is present, it is implied to be the principal square root. Let's start off with some basic examples. If we look at a, we have the square root of 64. In order to calculate the square root of 64, I want to know what squared equals 64. Since 8 squared is equal to 64, the square root of 64 is equal to 8. Let's look at b. b, ignore the negative for now, and let's just talk about the square root of 49. So the square root of 49 is equal to 7, since 7 squared equals 49. From here, since the negative is on the outside, I'm just going to go ahead and keep it. So our final answer is -7. If we look at example C now, example C, we want to know what is the square root of 1/4. What times itself equals 1/4? Well, what we can do is we should be able to hopefully know that 1/2 times itself, if you multiply straight across, you get 1/4. Another way that you can do this, and we'll explore it in the next section, is you can break up the square root by taking the square root of 1 over the square root of 4. Now let's look at D and E. D tells us we want the square root of 9 plus 16. We want to make sure that we follow order of operations, so I want to simplify inside the square root, giving me square root of 25. And now if we simplify the square root of 25, this is equal to 5, since 5 squared equals 25. Let's look at example E now. This one looks very similar to example D, but let's see what happens if we follow order of operations. Order of operations, I want to simplify the square roots first. If we do that, we get the square root of 9 is 3, since 3 squared equals 9. And the square root of 16 is 4, since 4 squared equals 16. Now we can go ahead and add the results, and we get 7. The main thing that I want to point out about example D and E is that you cannot distribute a square root over addition. Square roots are essentially exponents. We'll see this in the next section. And so the rules that we have for exponents apply to roots as well. Remember that you cannot distribute a square over addition. Similarly here, you cannot distribute a square root over addition, or subtraction for that matter. Finally, let's look at the last one. The square root of -81. Can you think of a number that if you square it, you will get negative 81? No. Anytime you square a number, squaring a number is always going to result in a positive. And so if the negative is inside the square root, what we say is this is not a real number. It's not undefined, because undefined is reserved for dividing by 0. It's also not the same thing as no solution, as we are not solving. If you this is allowed in the next number system, which is complex. If you recall, when we talked about number systems in general, I did mention that there is something called the complex number system. This is an example of what we would call an imaginary number. You do not need to know this. For right now, all you need to know is it is not real. That's some basic things that we're going to need when we talk about simplifying square roots or evaluating square roots.